This is the tutorial on how to use the PDE tool in MATLAB, and I have already created some pre-existing files in PDE tool to show the distribution on the concentration of the drug through the artery wall. So this is the simulation that I have at the moment. I've created two circles to establish inner and outer boundaries. For the PDE part, I entered the diffusion coefficient of 1 and volume source of U, which is just a variable for concentration here. We can use these triangles, I guess, to see the concentration distribution, and the more triangles you use, the more accurate the result will be. And in the end, this is the gradient of the concentration within the from inner wall to the outer wall, which the inner wall concentration initially was 2 and the outer concentration was 1. We consider all the variables here dimensionless, and we set the boundary conditions by just clicking on the boundary, and here under variable R you can see the concentration of 2. And how we export all the information we got here into the MATLAB file is export mesh. All the variables remain the same. I was not changing them at any point. We set the solutions to nonlinear solver, Jacobian full, okay. And export solution, U variable name is for concentration. I left it the way it was. And you can see all the variables are exported into the workspace. And as we click, here's my file for solution. If we run it, it's supposed to show us the concentration distribution. Yes. This is the concentration distribution, almost linear, as you can see. File, we save the picture as JPEG, so we can use it somewhere else. Further, part 2, a circular vessel, let's call it this, and then we save it. So, exactly. The second file is pretty much the same, except for the fact that the boundaries are now changed from circular to elliptical. Inner boundary stays 2, outer boundary stays 1. The most important one is the setting here. It initially states as generic scalar, change it to diffusion to avoid any mistakes. All the other settings are also the same, so boundary conditions set the same way. PDE, this stays U. As you can see, nothing has changed. I kept the color grid the same because I really like the colors. Exporting mesh using same variables, just gonna run the same code, and they're gonna show the results with respect to this problem instead of the previous one. Solution, parameter solution stays the same. And export solution, U, same variable, just gonna run the code once again. And here we run the code once more. You can see the concentration profile has changed a bit. Not much, but it did change, and we're just saving them as part to be elliptical vessel. Save. And the final part was concentration profile for rectangular shape, which we set to be just the rectangle. Upper and lower boundaries do not engage in any concentration distribution, so we changed them to Newman, just zeros here. This boundary was set to be 2. This boundary is 0. As we increase the mesh division into triangles, as I said, the results are much more accurate. And here's the concentration distribution for this part. You can see the max is 2 at the boundary where it was set to be 2, and 0 is final on the other boundary. And this was the tutorial for the PDE modeler. Yeah, this was my video on PDE tool in MATLAB. Thank you for watching.